Okay guys, video number 2. So we should be relatively happy that we can show the electron arrangement of atoms in the periodic table by looking at the small proton number, remembering that it equals the number of electrons. So the numbers of protons and electrons are always the same, and that's that number 3. So lithium has 3 protons, and that means it also has 3 electrons. And as we fill up those energy levels, we remember that only 2 electrons can fit in the first one. And after that, for GCSE, we learn that subsequent levels can hold up to 8. You can see on this diagram that we've gone to some much larger atoms where we start to get 18 electrons in the outermost shell. But although that's interesting, we don't need to worry about that for how we're going to explain the reactivity of group 1. So the first column in the periodic table, group 1, sometimes you see hydrogen drawn above it, other times hydrogen sits in the middle. Okay, hydrogen is quite tricky to decide where it goes. So we think of group 1 as lithium, sodium, potassium, rubidium, cesium. All of those are metals. Now you can see if we write out or draw the electronic structure of group 1 that they're in group 1 and all of them have 1 electron in their outermost energy level. Even when we get down to rubidium and cesium, which are larger, much larger atoms, then we've still got the characteristic 1 electron in the outermost shell. This means that all of these metals behave in a similar way, but the reactivity gets bigger as you move down the group. The elements get more and more reactive, and we need to explain that in terms of how easy it is for these atoms to become ions. So all of group 1 will lose 1 electron and give it away when they react. Because lithium's outer electron is the closest to the nucleus, and the nucleus is pulling on the outer electrons because it's got positive protons inside it and the electrons are negative. So we think of these negative electrons being attracted to the positively charged nucleus, and when they are closer, the pull is stronger. So lithium holds on to its outermost electron better, more easily than cesium, for example. Cesium is the most reactive atom shown here because its outer electron is furthest from the positively charged nucleus, and therefore the outermost electron can be given away easier. Cesium reacts easier, it is more reactive. So to recap, make sure that you understand that the group number tells you how many electrons are in the outermost energy level, that as you go down the group, you're adding more and more full shells of electrons, and so the outermost electron is getting further and further away from the positive charge and the force that the nucleus tries to hold on to those electrons and keep them in orbit. So as you go down group 1, and the same would apply to group 2, and the same would apply to group 3, as you go down those groups of metals, they get more reactive because they want to give away their electrons.